Okay, I know you're like me and I wish I was still on break, but they haven't decided we can just have a month off, sadly enough. Maybe one day. Life goals. When you walked in, I'm sorry it's a giant packet. I swear my next to yourself will make it a smaller packet. It has space even though you don't need space. It doesn't have, nobody has time to fix that. It is your semester exam study guide. Regardless of your exemption status, it must be complete. It will be a, let's see, how many questions are there?
124.
Oh, it will be a 124-point grade in the 30% category. Now, which means, I mean, it's not in the 60, but it's still not in the 10 either. So it'll make a big impact, or it should help in a lot of ways. The good news is, I'm going to give you the answers. So how you don't get a perfect score on this, I don't understand. Because I'm about to go over at least the first 10 answers right now. So every day, as long as you're paying attention during math workshop, you're going to get all the answers done before the exam. That's really all there is to it. Should be a nice, easy grade. There are some problems we're going to skip because they're not going to appear on the exam. And then so I would just like flip through Kenzie's packet and see, like, did she cross out number 4? Because I'm not going to do number 4. That's what I'm going to look at. Was she paying attention? Okay, besides that, some people were not here with us right before Thanksgiving break, or some people still aren't with us now. They're on their phones and their grades are dropping and dropping and dropping. I refuse to look up your exemption status until Friday. You'd say, well, I'm Miss Compton, I need to know. Well, I have many reasons. One, you have a test on Friday, so I have a little free time. 2, there are some people who weren't here last Monday and Tuesday, so they missed a really important 60% grade because they missed their math workshop test, and they missed a really important 30% grade, which is completing the square and quadratic formula quiz. I told you I wouldn't type in the zeros till after the break. I'm going to type in those zeros come Friday. So you want to, if you're one of those people and you missed those 2 assessments, you want to fix that by Friday. On Friday, I'm going to type those zeros in and consider in those zeros would I tell you whether or not you should or should not be exempt from the exam. But you realize all that is subject to change depending on how you do on the test on Friday as well. So many variables in life. Too many, I would say. Goodness. And, of course, you turning in this packet and it being beautifully done. Things to discuss. Well, I did not type in any zeros for the math workshop test or the completing the square quadratic formula quiz. I did type in zeros for 2 missing homework assignments, and that was a lot of zeros. So I do want to at least look at those now. Do you have out your notes? Remember those notes? We had a packet. We weren't done with it. That's the packet we're on today. Do you have out your number strip?
Yes.
Okay, in your notes, the bottom right should say 22, or the first page says 21. We did that together. We did page 21 together, but page 22 was your job. I told you the answers, and you were supposed to do it. So have you done page 22? And have you shown it to me? Have you done page 22? That's one of the zeros you probably have completed. All 5 on page 22. Okay, and then flip to the next page, page 23. That's the other missing homework assignment for most of us. I've done my page. You were supposed to do these 5 quadratic formula problems. Most people did not. Okay, some people took the math workshop test. Math workshop test we're not fixing. If you failed that, I'm so sorry. The ship's done run. However, if you failed the completing the square quadratic formula test, you would like to redo that one day this week. That's definitely an option for you. I had some blogs in the room, and the title would say, the title in the first 2 questions specifically said, solve by completing the square, and you know those fools use the quadratic formula. How can I give points for you completed the square if you didn't complete the square? Okay, and then I have some who didn't finish, and you know who you are. You got to get on top of your life. I don't have, it's the end of semester. I'm doing the best I can. I don't have time to say, Mia, did you finish your quiz? Because Mia knows whether or not she did. She can handle this. She's a big girl. She's got this. Okay, are there any questions about the missing tests or homeworks? Okay, then let's go over some of these semester exam study guide answers. Today I'm going to work some of them out because you just got handed this today. How could I expect you to already know it? As for tomorrow, I'm probably just going to go over the harder ones. If it's a super easy question, I'm probably just going to say the answer is A and move on. Okay, so number 1 of our semester exam study guide packet, it says that A is 2 and Y is negative 3. So it used to be A minus Y squared plus 2Y to the third. But they told me A is 2 and Y is negative 3. So I'm literally just going to plug in 2 and negative 3 in the appropriate spots. The issue is that some people are going to make sign errors. 2 minus and negative 3 should be a point for table 1. 2 plus 3, which is 5 squared, which is 25. Over here, negative 3 to the third is negative 27. 2 times negative 27 is points table 6. Negative 54 plus 24 is another point table 6. So number 1 is A. And literally all we're trying to check is, can you keep up with things? Do you pay attention to signs? Number 2 is what kind of a problem? Another point for table 6. Okay, so it was absolute value of 3C minus D. And they said C is negative 1 and D is 5.
It'd be positive A.
No.
Because the 3 times 1 would be the negative 3, then minus 5, it would equal to negative 8. And then...
Well, I mean, I guess the 3 times negative 1 is negative 3. Negative 3 minus 5 is negative 8. But what did the bars do? They turns it into a positive. So that negative sign's still on the very outside because that negative sign's not inside the bars. But the negative 8 inside the bars is just negative, is just positive 8 now. So the answer should be D. Again, they're just trying to trick you up with those signs. Just trying to trip you up with signs. Number 3, it says 4m to the third minus 3m squared plus 2m minus 2. And they tell you that m is negative 1. And I do want to point out on number 3, if you are one of the unlucky souls who has to take the semester exam, which, no offense, is normally a lot of people in first period because you couldn't all get here all the time all year. I got it. If you are one of those souls and you're having an issue like on number 3 with the exponents being so tiny, if you'll ask me during the exam, I will help you on that because that's a good question. Is this a 3? Is this a 2? Like, you need to know. Okay, so we've got negative 4 plus 3 minus 2 minus 2. So yeah, I've made a mistake, haven't I?
Yeah, you forgot to add the exponents.
I did. So I did not, and you can have 2 points for that, or sure.
How much that would all, which that...
So negative 1 cubed is still negative 1, but negative 1 squared is positive 1. I knew my answer wasn't one of the answer choices, so I knew I had gone wrong somewhere. That's the beauty of the semester exam, at least it's multiple choice. So I've got negative 4 minus 3 minus 2 minus 2. My answer should be, it is negative 11, which is B. Okay, you can put an X through number 4. I promise you, if they decide to put that bad boy in the semester exam, I'm going to tell you the answer, because nobody has time for that. They would literally want you the sum of the first 20 natural numbers. So plug in 1, plug in 2, plug in 3, go all the way to 20. Nobody's got time for that. No, number 4. There is a faster way, yes, but not happening. So put an X through number 4. Number 5 is where we get to your favorite things in the beginning of the year. We've got a couple questions like that. We have to remember our number systems. We started off with natural, then there was whole, integers, real, rational, irrational. We had this whole number system unit. So which one of these is a rational number? Okay, what is the square root of 36? It's just 6. Wasn't that called natural? Okay, so we're not looking for that one. So you're actually trying to pick. Oh, actually it is B. Miss Compton is going crazy today. Woo. 5 is B. That's what my key says. The reason it is, and I know why, and I'm being slow. If you remember, we had a math workshop question on this not too long ago, actually. If it's the square root of something that's not a perfect square, like 50, then when you type it in your calculator,
It comes out as a decimal.
it's a decimal, and it is terminating. So it would be a, oh, I need my light on. It's a decimal, and it looks like it's terminating, but it's not got a nice pattern, kind of a pain in the rear, so that's why it's going to be not a rational number, so therefore we went with B. I'm with you. It's been a while since I've done my number systems, and if that's how you feel, you kept up with your notebook this whole time for a reason. Maybe look back at your notes on number systems. Which one of these is irrational? Remember, irrational was supposed to be non-terminating.
A.
Terminate. I'm trying to spell terminating, and I can't even. And non-repeat. And there is no pattern. Non-repeating.
Well, at least you have the terminating, right?
Yeah. Okay, so we know it's not C, and we know it's not D, because both of those kind of imply we're repeating.
A.
We know it's not B because it terminated. So yeah, it has to be A. And if you wanted to check that in your calculator, 27 divided by 5, I got 5.4. Oh, Miss Compton is being blind again. You know, I gotta look down at the answers before I start doing math after a long weekend. Lord Jesus, help us all. Okay. I'm gonna write my answer choices again because I done gone crazy. B, C, and D. I agree it's not B because that bad boy terminated. I agree it's not C because of that. Bar over the top means it was repeating. And I was with you on choosing A until I typed it in my calculator. And 27 over 5 was 5.4. That terminated. So it's not A. So the answer is actually D. You know when they put the 2, 5, 7, 3, ... I guess that ... doesn't necessarily imply 2, 5, 7, 3 again. I don't know why in my head this morning I decided it did. Clearly I've had too much turkey. Yes. So like it has a set end. Like after 3 it stopped. After 4 it stopped. Did it stop? Okay, let's go to number 7. Okay, negative 28. We're going to decide which number system it belongs to. It could belong in multiple, remember? We know it's not a natural because it's a negative, so it's definitely not D. You think D? You would be correct and you can have a point. It is an integer. It's also rational, but heck, it's also a real number as well. And I'm with you if those are a pain in your rear. I know there are at least 2 on the exam. And I know it's been a while. It's been a long semester. It is what it is.
How many questions is on the exam?
I'm sure it's 100. If I guess. It might be 50. I don't actually know. I'm not actually handed it. I have to flip through it. It's probably 50. No, I'll take that back. It's probably 50 and 2 points each. That's what it normally is. Okay, if I distribute that 1/2, I would have 4y minus 5z. I distribute that negative sign, I'll have negative 3y minus z. If I combine my like terms, 4y minus 3y, I get a positive y. Negative 5z minus z, I get negative 6z. So my answer choice is A on number 8. Most of us can do this, but there are still some in the room who are determined to not combine like terms. I don't really know. It's kind of funny, but not really. And let's finish out this page. So number 9 says, solve the algebraic expression that represents the verbal expression twice the sum of a number and 8. Twice the sum of a number and 8. So the sum of a number and 8, and then twice that, it does make sense for 9 to be C. I heard it from 1 and 3. You can have a point. Okay, number 10. We're going to finish out this page today. Select the algebraic expression that represents the verbal expression 5 increased by 7 times the number.
D. A.
The answer, so 5 increased by 7 times the number. 7 times the number, wouldn't that be 7n?
Yes.
And then increased by 5, so plus 5. So it's got to be 7n plus 5, which is D.
Well, I said that.
If you said D, I know 6 did. If you said D, you can have a point. $11 is going to be a bunch of fun. We get to distribute. Now, notice how, even though this is multiple choice, I actually show math. That's the problem when people take semester exams. They suddenly think multiple choice means I don't need to write any math down. I just guess answer choices like you a genius. I'm not a genius either. I have to show math. Okay, I distribute the 3, and I would have 15x minus 3 equals 3x plus 3. And it would be nice if you could see that. I'll put the x's on one side, so subtract by 3x on both sides. So I've got 12x minus 3 equals 3. I add 3 to both sides, I get 12x equals 6. I end up getting x equals 6 over 12, which reduces to 1/2, so the answer is A. Okay, number 12 is probably my favorite one of the day. I think it's the easiest. You want to tell me the answer on number 12? I heard someone say it. It's C. Now remember, an absolute value problem, that's what's half our issues. I remember writing this like 1,000 times on every test. Absolute values has 2 answers.
Where the 4 could either be a positive or negative.
Yes, we're not sure, so we know the inside part was x minus 5. We're not sure if the inside part was equal to positive 4 or was the inside part equal to negative 4. We know those bars made it a positive 4, but before the bars existed, was the inside part positive 4 or negative 4? We're not sure. So if we solve this one, we get x equals 9. We solve this one, we get x equals 1, which is how we got to C. Okay, we knew the answer choice wasn't D. When would the answer choice be D on an absolute value? 16 a point. If we're trying to set absolute value equal to a negative. So if we had done the whole thing with the bars equal to negative 4, that's when we would have picked D. Because the whole thing with the bars cannot equal a negative. Absolute value makes everything positive. No way this entire term can equal negative 4. Okay, are there any major questions about 1 through 12? Then if I were you, I would try some of these out on my own because I know I worked through them today, but again, it was put in your hands today. We're going to try to do, we did a complete page today. We're going to try to do a little more than that tomorrow. Our goal will be to get to 29. That's a goal. I'm not saying it'll happen, it's a goal. Okay, back to your notes. I know it's been a while since we've talked about quadratics. I know you've had a couple days off and you kind of hoped they would leave. The bad news is they don't leave until Friday. The extra bad news is Friday is your last 60% grade for this semester. Yep. That is a lie. I think we're doing a 5.1 test and we're putting it in the 60. I think that's a lie, Gracie. I think you're right and you get a point for that. I'm telling you, brain is off. So that's our last chapter 4 major assessment, yes. Okay, so what we're doing today is something a little new. We're going to do 4 problems and then you've got 3 problems to do in the workbook. But honestly, we're going to do this pretty fast. And then Seth needs to go back and fix page 22 and 23 in his notes because he's still not done that. We're going to write a quadratic function in Vertex form. So just a reminder, quadratic functions, something raised to the second power. We used to spend a lot of time describing quadratic functions. We talked about how to graph them and find stuff from their graph. You can still, I'm never taking the graphing calculator away from Kenzie, so she can always check herself with the graphing calculator. Today, we're going to write it in Vertex form, but if you read above, it says we still want to know the axis of symmetry. We want to know where the vertex is. We want to know the shape of the parabola and the direction in which it opens. So I'm going to need to know that vertex. I'm going to need to know that axis of symmetry. I need to know the shape, which is one thing we haven't spent a lot of time on, but we did with absolute values, so it's not going to be a big deal for you. And then direction, as in opens up or down.
What do you mean by shape?
We're going to come back to that, so you can put a star by it. Okay, I don't even have to put it in vertex form to know the direction. Is this going to open up or open down? 3 can have a point. It's going to open up, and I know that because it's a positive number in front. Remember, if it's a negative in that very first term, the part with the x squared, then it opens down. And again, Valeria can always check herself by graphing it on the calculator. Now, I know there are many in here, well, all of us should be able to graph it and figure out all this from the graph. There are some in here who even learned the negative b over 2a trick for the axis of symmetry, and that's great. That's great. But it says specifically write in vertex form, so if we don't actually put it in vertex form, have we actually done what we were supposed to do? No. Okay, so we're kind of going to do this the way we did completing the square. So if you zoned out on completing the square, God bless you. Okay, so I'm going to put x squared plus 4x. I'm going to ignore the 6. I'm going to put plus something. I'll put the plus 6 on the outside. Now, when you and I were completing the square, if we added something to one side, then we add it to the other side as well. But today, I'm not really wanting to do anything with the y. So what we're actually going to do is subtract it. So basically, the thought is, like, if we add 3 to these two, and we subtract 3 here, hasn't it evened out? Like, we added 3 and we subtracted 3 on the same time. Doesn't that still add out to 0? So whatever number we add by, as long as we subtract by it, we've done well. Okay, we had a trick when we were completing this square. We were supposed to take the middle term and do what? Divide by 2, 3 gets a point, and 4 gets a point. You divide by 2, that's the number that goes down here, and then what did you do after that? You square it, 3 and 4 again. So 4 divided by 2 is 2, 2 squared is 4. So I'm literally going to add and subtract 4. That's my magic number. Again, I'm still doing middle, divided by 2, and then squaring it. I did 4 divided by 2, got 2, 2 squared is 4. So my magic number, still determining it the same way. But now instead of adding the magic number to both sides, we're like counteracting with the magic number. If I add 4 and subtract 4, that evens out to 0, so it's okay, I haven't broken any rules. Okay, 6 minus 4 is a positive 2. So technically here, we put it in vertex form. Now, what that means is you and I, looking at this equation, should be able to identify its vertex. Like, I know it's crosses here, on the, like, its bottom or top point for this one, since it is opening up, it would be a min. Its min is at this point, and I can tell it from this equation. I don't remember how much you remember. I don't know how much you remember. We did something like this with absolute value. The plus 2 on the outside means up or down 2. It still means up 2, but there was a trick for the thing on the inside. The plus 2 on the inside, does that mean right or left 2? You would think right, but remember the inside was opposite of what you thought, so it ends up being the opposite sign. We did this with absolute value. It's the same with quadratic. Honestly, it's the same with any kind of function. Once you put it in this vertex form, this coordinate is always the opposite sign. But the outside coordinate is what you think. Okay, for 2 points, what's the axis of symmetry? Is it 2? 3 and 6 get a point. 2 points. Remember that axis of symmetry and that x-coordinate of the vertex, they do match. They're supposed to match. They're supposed to match. And then as for the shape, we're really wanting to know, remember when we were doing absolute value, we would talk about if we shrunk it or if we stretched it, we could be fat or skinny. Since there's a 1 in front out here, we're not messing with its shape, so it's really not important for this one. But like in the next one we do, we're going to end up taking out a 2, and that's going to end up stretching me and making me skinny. So it's back to that fat, skinny world. This one's neither fat nor skinny. Okay, are there any questions on number 1? Then let's do, yes? Yes. So it's back to this outside number, which I'm saying is a 1. Does it make me fat or skinny? Since it's a 1, it doesn't change anything. I stay the same. So it's not important for that one. It'll be important on the next one.
So if it was like, say if it was a 3, what would you put?
Remember, fractions make you fat. So as long as it's not a fraction, I'm going to put skinny. Fractions make you fat. Okay, so I still on number 2, I'm going to want to know the vertex, the axis of symmetry. I actually am going to want to know the shape on this one. And then the direction I already know is up because it's a positive 2 in the front. Okay, so again, just thinking like we were completing the square, I'm going to put the 2x squared minus 12x plus something. And then plus 17 minus whatever that something is I come up with. Now, when we were completing the square, we made life a little complicated. We tried to do Miss Brister's slide, divide, bottoms up kind of thing where we slid that 2 on down. Instead, today we're going to make our lives a little easier. We're just going to pretend, well, we're not pretending. We're literally going to make that 2 a GCF and pull it out of every term, or every term in the parentheses. So if we pulled it out, we would be left with x squared minus 6x plus something. We're still working on it. I know I should write down the plus 17 minus something, but I'm going to come back to it. Leave it be for a second. Let me finish completing my square. So I pulled out a 2. My middle is a negative 6. So if I take that middle and divide by 2, what do I get? Shouldn't it be negative 3? Okay, I heard it from 1 and 6. You can have a point. So middle divided by 2 and then squared. So negative 6 divided by 2 is negative 3 squared. It ends up being positive 9. I get that I've got to go back to the top and fix something. I'm getting to it. Are there any questions about how we completed the square? So I already know the x-coordinate of my vertex is going to be a positive 3. Okay. Now you and I both know we pulled out a 2. So if we were to redistribute that 2 to everybody, I didn't actually add 9 to both sides. I'm actually adding 18. Or adding 18 and subtracting 18. Again, since we pulled a 2 out of every term. That means before we pulled out the 2, it was really 2 times 9. So really, we need to add 18 and subtract 18 from both sides. So let's say that again. So we did middle divided by 2 squared. So we got negative 3 squared. We got positive 9. We had factored out a 2. So if we were, and I'm now looking up backwards, it used to be 2x squared. 2 times negative 6, negative 12x. So it used to be 2 times 9, and that was 18. So instead of adding 9 and subtracting 9 from both sides, I actually need to add 18 and subtract 18. Because again, you and I pulled out a 2. So we've got to give that 2 back to that 9. We do. Okay, 17 minus 18 is negative 1. And that's when Miss Compton gets lazy and just writes negative 1 on the next 2 lines. Once I figure out what that magic number was, I don't keep putting 17 minus squiggle. Once I know it, I actually do the math and move on. Okay, so that means my vertex is at 3, negative 1. Because it's the opposite sign for this, regular sign for that. My axis of symmetry is 3, table 3, I have a point. And then as for the shape, because of this 2 on the outside, if we were to graph it on our calculator, it ends up stretching you and making you skinny. So you can either put stretch, or literally if you put skinny, I'm cool with it. And just as a reminder, we did this a lot with absolute value. If there's a whole number out front, it makes you skinny. So I was like this, now I'm skinnier. If there's a fraction out front, it tends to make you rather large and fat. Okay, are there any questions about number 2? Number 3. It's going to be a little easier. Why is number 3 going to be a little easier? 3 and 6 counterpoint. That leading coefficient of 1 means my life's going to be good to begin with. So I really am not even worried about the shape. Because again, it's not going to change. And I already know the direction is that it's still pointed up. Okay, so I'm going to try to complete the square. I had x squared plus 2x. I want to add something. And so whatever something I add, I need to subtract 7 by that something. I still use my same logic of middle divided by 2 squared. It's going to be x plus what number? 3 and 6 get a point. It should be middle divided by 2 is 1. 2 divided by 2 is 1. And then square that. What's 1 squared? 1. And again, if you still want to do all this in your calculator, you can. So since we're adding 1, we got to subtract by 1. 7 minus 1 is positive 6. Are there any questions on number 3? What is my vertex? Hunter, your group can have a point. My axis of symmetry is negative 1. Again, shape is not going to change because there's a 1 out front here. Number 4 is our first interesting one. Well, it's not our first interesting one. The others are interesting. That's the first time I get to write what word. 3, get another point. Because there is a negative out front, it's down. Because there's a negative out front, it's down. He's being sarcastic. Let it go. Okay, so I'm going to put negative 4x squared minus 24x plus something. I don't know what that something is. I'm working on it. And then I've got a minus 15, and I'm going to subtract that something. Okay, I get you, and I don't know what this something is yet. I get that's what we're working on. But just looking at the negative 4x squared and the minus 24x, what's the GCF we could pull out?
4.
Yes and no. Yes, 4, but be more specific. So we pull out a negative 4, we're going to have a point. if we pulled out a negative 4, we would be left with a positive x squared, a positive 6x, and then we still just don't know. We're still just working on it. And I get I should keep writing stuff on the right, but again, I'm lazy. I'm going to come back to that very end in just a second. Okay, so I pulled out my negative 4. I need to do middle divided by 2 squared. So middle divided by 2, that's 6 divided by 2, which is 3. 3 squared is 9. Are there any questions about how I got the 3 and the 9 on my paper? Okay, but if I'm looking back at that top line, I'm not going to put a 9 and subtract by 9. I got to times it by negative 4. Because if we're thinking back through this distribution, it used to be negative 36. Because negative 4 times 9 is negative 36. Again, we pulled out that negative 4. We got to give it back to the 9. Negative 4 times 9 is negative 36. And lo and behold, we're having another one of these issues with so many signs going on in life. Lo and behold, we're having this issue with so many signs going on in life. It is going to be, thank you, Natalie, for saying the words out of my mouth. You get on point. It ends up being negative 15 minus the negative is plus 36. And 36 minus 15 is actually what number?
21.
That feels right. Yeah. Okay, so my vertex is at negative 3, 21. So we would definitely have to zoom funky on this one if we graphed it on our calculator. Our axis of symmetry is negative 3. Our direction is down. And tell me about the shape.
Very stretched and skinny.
It is definitely stretched. And it's more stretched than the number 2 was, or skinny. Because negative 4 is a 4 is a larger number. So I was skinny with 2, and now I'm super skinny with 4. Imagine what 8 would make me do. Hey, are there any questions about this? You have a couple minutes. You really could get your 3 done in your workbook. Or if you need to work on your other missing homeworks, that would be wise. I do have some tests to show some people in the next little bit.